morning everyone and welcome back to the class of eye. Students, in the previous video, we have started the chapter eye, and in this I have taught you the structure and the function of the eye. I taught you that what things are present in the eye, what is their exact location and how do they perform well. Okay, so we saw all the structure and function of the eye. Now today we will see the eye defects and their correction. We'll see that how many types of defects can be there in the eye and how we can correct them. So about the defects, there are various defects found in the eye like myopia, hypermetropia, cataract, astigmatism, presbyopia, night blindness, color blindness, and so on. So there are various types of eye defects. Okay, and we'll see one by one all of them. Now number one is myopia. This myopia is also called as short-sightedness. Short-sightedness, remember the word, or near-sightedness. The meaning of myopia is when your near vision is clear, when our short sight is clear, but we are not able to see the distant object, then that is called as myopia or short-sightedness or near-sightedness. Okay, so what is the definition? When our near vision is clear. Near vision is clear, but what is not clear? That is far vision is unclear. Then that is called as short-sightedness or near-sightedness. Now see children, how this defect can occur in the eye. What are the causes of this defect? Number one, when your lens become too thick. Okay, children, as I told you that thicker is the lens, higher is the converging power. Okay, according to the physics, I have already taught you this thing in our live classes that thicker is your lens. Understood? High will be your power of convergence. If your convex lens is thick, okay, then the power of convergence will be very high. Clear? So this is one of the important cause of myopia, that is lens become too thick. Now how it works, you see. Suppose if I draw one eyeball. Okay, this is the eyeball. I have already taught you. And then suppose if this is your cornea. Clear? And here ciliary muscles. Rest everything I am not going to draw. I'll just, okay. I'm going to make a small ciliary muscle and suspensory ligament and the lens. Because of the adjustment of the ciliary muscles and suspensory ligament, what happens? The shape of the convex lens changes and it becomes thick. And just imagine children, if the ray of light is coming from the near object, some object is kept here, then the rays are diverged in this way. This everything I have explained you. Rays are diverged like this. Now they will enter into the lens, and because of this high divergence, they will converge and they will form on the retina in the normal situation. Okay, so my near object is 100% okay. But what happens if the object comes from the far side, that is from here. Now I am drawing it with green. Okay. If the rays are coming from this side, then automatically the rays will change into parallel. Okay, parallel. Now the rays are not diverged too much. The rays are already little bit parallel. Now, when they will fall on the convex lens, because of thickness of the convex lens, okay, they will converge and form the image somewhere here. Because the lens is thick, so lens will converge them too much. And they will form somewhere here. But this is not the retina. So where the image will form? Nowhere. Or we can say that a blurred image will form. Because everything is going inside the vitreous humor. So no image will be formed when the object will come from the far side. Okay. And this is called as myopia. This is the first situation of the myopia, that when our lens has become too thick, then it has increased the power of convergence. For the near side, there is no problem because the rays are already in the diverged form. If they will go to the lens, they will converge and they will fall on the retina. So no problem. Here we can find out the image. But what happens if the images are coming, if the objects are kept at the far distance? If the objects are kept at the far distance, then the rays will come and the rays has already become little bit parallel. According to the rule, this we have already studied, that if the rays will come from the infinity, then they will fall on the lens in the form of some parallel rays and they will fall at the focus. So this we know very well. So now the rays have already become parallel. Because of this convergence, they will converge, and after convergence, they will form the image somewhere here. And then we would not be able to see the image. So this is the first situation when the lens has become too thick. The next condition, when the eyeball become large, too large. So what is the next situation? That is our eyeball is too long than the normal. Okay, now see what happens to the eyeball. Once again, this is our eyeball. This is cornea. Somewhere object is kept here. This is your near object and this is my far object. But the situation is this. The object has become like this. Okay, and for the near there is no problem. Convex lens, it will converge and the image will form here. Okay, for the near because of the power of convergence. Okay, but what happens to the far objects? The far objects, they will come and if they will converge, then they will again form somewhere here. If not somewhere here, if they are coming to this retina also, but there is no retina. Retina has gone back. Why? Because the eyeball has become too long. So, once again there is a problem. Like for near there was not any problem. The eyeball has become long. So, eyeball will take this as a far image and then image will be formed. But what happens if the object is kept at the far? The image, the ray that will converge earlier and will not be able to see the far objects. So these are the two important reasons that is responsible for the myopia. Now children, how we can correct this? Our power of convergence is maximum. Okay? And we want to diverge this. From the figure itself, it is clear that because of the thickness, because of this too long eyeball, the power of convergence is maximum. And we do not want that it should be more converged. We do not want. We want that it should be little bit diverged. So if it will be diverged, it will form the image on the retina. And for this, what we can do? We will use concave lens. If we will use concave lens, then automatically, children, the rays will be diverged. I am telling you. Now see, this is the defective eye. Okay, this is the defective eye, and here I am going to use one concave lens. If I will use the concave lens and if the image is coming from the far, that image, that ray that will already become parallel, it will not become parallel because of the presence of the concave. It will diverge little, and if that diverged will enter into the eye, then through the convex lens, this will converge, and then this diverged rays will form here. So this is the correction, children. This is the correction. Actually, what was going to be happen here? Actually, the far objects, if without the lens, they were becoming parallel, and after becoming parallel, after entering into the lens, they were forming image somewhere here. But what we did? We put one concave lens. If we put one concave lens, then the rays that is going from here, the rays that is coming from here, coming from the object, it will fall on the concave lens. It will diverge itself, and that diverged image, that diverged rays, if it will form on the lens, then it will converge and form the image on the retina, and we will be able to see the things. And that's why, children, those who are suffering from the myopia or the short-sightedness, they use concave lens. Okay? And the power of the glass is given in the minus sign. This property you know about the concave lens. Okay? So you know very well that the power will become minus. So this is all about the causes and how we can correct it. Now how we get the disease of myopia? If a person is sitting continuously in front of the computer, okay, if your diet is not normal, or what can be the conditions? Continuous reading and writing. If we are concentrating the things for a longer time, if we are sitting in front of the computer system for a longer time, if we are using the mobiles for the longer time, then the rays that comes out from there, they will infect or defect, or they will cause a problem in the ciliary muscles. Okay, and our ciliary muscles will remain contracted. They will lose their lubricant and they will remain contracted. They will remain tightened and stiffed, and because of that, your lens will change its size and it will become thick. And because of that, the power of convergence will be maximum. If power of convergence is maximum, then ray of light will not form on the retina. It will form behind the retina. Like it will form in front of the retina, and then will not be able to see the image correctly. Okay. So this is all about the myopia. Now in the next part, we will see the hypermetropia. Okay. Till then, children, you revise these things. Thank you.